So hello, everyone. Thank you for joining June's SAP BTP Garage. So welcome back if you have joined us before, or welcome if this is your very first time joining us in the garage. As you can tell, I am a new moderator. So if you've joined this call before, you may have seen Toros Alegian, who was our global host for years. So we started the series around 3 years ago, and he has been hosting the global call for the past 2 years. He has now left SAP, unfortunately, so we were sad to see him go, but just so you know, that's why we've had a little bit of a moderator changeover. I will now be hosting the global call alongside Gaurav, who will host our APJ call. Let me go ahead and share my screen so you can see the slides, and then we'll get started. So here we go. I am very excited today to have two hosts with me. We have Anjana and we also have Vivek, and they both have over 10 years of experience with SAP. So as always in the garage, we have great experts who we are very happy that will join us and share their expertise with us. They are also going to be talking about a Discovery Center mission. Is the recording started, by the way, Vivek? I don't see the notification. Did it actually start?
Yes,
I got that. It did, yeah.
It is. Okay, just wanted to make sure. So the topic for today is harnessing generative AI capabilities with SAP HANA Cloud Vector Engine. So of course, very hot topics. So the Vector Engine, we're also going to be talking about LLMs. And since the beginning of the year and even a little bit before that, of course, AI is a huge topic. So thank you to our guest speakers for joining us today. So like I said, we have Anjana and Vivek. Unadi presented in the session earlier today for APJ, but she's also joining us in the chat. So if you have any questions, you can of course drop them in the chat, but we will provide a 5 to 10 minute slot at the end of the call to answer any questions live. This is the mission. So in every call, as you know, we go over one Discovery Center mission. So this is what the mission will look like. I will put the link to the mission in the chat. So if you guys want to follow along and access it as Vivek and Anjana are presenting, of course you can. That's where you'll be able to find the Git repositories and any of the sample coding that they provide, as well as the step-by-step instructions for implementation guidance. And also the solution diagram. So it's where all of the resources that they cover today will be located, as well as the slides for today's call. Like I said, the call is being recorded, so we will upload the recording to YouTube. We have an SAP BTP Garage playlist that's available on the SAP community channel. I will also provide the link to that. And with that, I will hand over to Vivek. Maybe you guys want to introduce yourself first and then jump right into your topic.
Sure, Cecily. Thank you. Maybe let me quickly share my screen. Let me know when you see it.
We can see it.
Perfect. Let me see. Okay. So thank you again. Thanks for joining the session. And we have the colleagues, Anjana, Unnati, and myself, Vivek. We are part of Center of Expertise, North America, and we command the Customer Success Delivery Organization, customer-facing roles. And we are more than happy to present this discovery mission, focusing on HANA Cloud Vector Engine. So before getting into the mission itself, right, there were a couple of basic slides which we want to talk about the terms what we use, talking about vector engine and some of the concepts what we use. And then immediately we will jump into the discovery mission, discuss about the architecture, why we chose that, and some of the deployment scenarios. And of course, we have given the code repository for scripts and also for the CAP application. And we also interestingly shared some benchmarks towards the end. And if you're interested, once you are there in the discovery mission, you can request us to discuss more about the benchmarking of performance, and we are more than happy to do so. So moving on, right, from the vector point of view, I'm not going to take much time here. We wanted to focus on the hands-on, but discussing about any of these different kinds of data sets, right, with the evolving of generative AI, a lot of enterprise applications, specifically within SAP, the vector engine is going to be a backbone on which several applications would be built, say that our SaaS solutions, which runs on HANA Cloud or any of the systems which are using it. But at the end of the day, if we have to process some unstructured data or maybe audio, video, or even today with evolving large language models, even if it's for the structured data, the way on how a business user would be able to access it without running numerous data pipelines. Like, is it possible that I could directly access the text and I could query asking to it? And for that, there are a few things and concepts needed. To start with, it's something called an embedding function, meaning that the text has to be converted into a format in the form of vectors, which would be, say that we could show it in a three-dimensional space. So based upon the way on how the data is available, and we would be able to use it for building applications like similarity search, or maybe like for running some query, or even building some knowledge graphs or some applications on top. So the concept of embedding function is very important, and SAP doesn't provide us such, but we provide via our generative AI hub access to different large language models provided by partners at this point, which would help you understand on how you convert your text or any kind of data into a vector. And for that, we help with the embedding function. And specifically, how do you deal with the text? Because there are some limitations with the large language models itself. It would accept certain length of tokens of data. And for that, if it's more than that tokens, what it would handle, then you would hit something like a rate limiter. So how do you chunk the data? Like there are different frameworks available, and one of the framework is LangChain. So when we build all these applications, we try to build within the SAP space, where we provide our vector engine as part of HANA Cloud, our generative AI hub, a lot of these things to make sure that when the user prompts, it always goes into the right resources where it has been trained, and not over the internet and bring some hallucinations inside. So these are some of the core concepts which we will see as we move in. So we talked about vector, we talked about what is embedding function, right? So how does it translate within the HANA Cloud space? So by default, in the HANA Cloud post Q1 2024, you will see a data type called vector, real_vector. And that would be the way on how I would be able to store text or any kind of unstructured data format. And on the right side, you'll see that if I'm giving the data type as real_vector, I also provide a dimension. I will discuss about that when we go into the hands-on part. And the important point being, like, you convert your text or any of those information into a vector, how do you retrieve it? Like a business user asks a question, so the system should be able to find that the user asked for some of the sales order details, it is converted to vector, but I wanted to find the closest vector in the system. So that's where these vector functions helps you. And we have cosine similarity, Euclidean distance, and other new functions that's been added as part of our vector functions too. And in order to use all these different capabilities, most importantly, it supports via SQL. I could run a SQL to see a vector search. And from the toolkit point of view, we support using Python, and we also support using Node.js. And seamlessly, SAP also has developed a LangChain plugin. And more importantly, apart from using it for Python, for running the data and having it in the form of the embeddings, if you want to build similarity search applications, we also provide the support for using CAP. And more importantly, to access all the large language models, you access it via our generative AI hub. But it also doesn't stop you from using from the open source directly, or maybe from Azure, or maybe from AWS if you're already using it. And from roadmap point of view, towards the Q3 of this year and later, you'll see the support for vector index, because quickly the concept of knowledge graph is also evolving, might be something needed. And more importantly, for NSD storage, and you would be able to use the support there too for the vector. Okay, this is some of the basic concepts which we will talk using the mission. But more importantly, I wanted to talk about this architecture, and then we will delve into the discovery mission. One of the background for this is, like, the last year, we have been working on different vector database providers. Like VectorDB from HANA Cloud was available from March this year, but we were doing some kind of benchmarking and also trying to understand the comparison. And we were working with some of the customers, and interestingly, there was a pattern we found. Take an example of one of our medical customer who has a call center. So they used to get the calls where the users talk about the services or maybe some feedbacks or complaints. You get all this information, and those calls are transcribed as text, and it's available in the file server, right? So the day-to-day workers, the pipelines of this data, they run some data engineering pipelines, convert it to a format, cleanse it, and provide it to business, saying that they can look into it for what are the requests or what are the feedback opportunities they have. One of the requests what they had was like, can I query these text files directly for the business instead of running all these pipelines? Like, I just want to go today and see that what are all the opportunities we got this week, or maybe the feedbacks to streamline the business. So that's when all this natural language processing capabilities kicks in, and that's where the need of vector engine within the HANA Cloud also made a lot of sense for building these applications. So as part of this discovery mission, you would be able to see the different steps what we covered. For example, some of the customers were able to extend it and use it for their own use cases. As a part of this mission, we gave some schemas where you have some JSON documents and also like the relational data. You could ingest it directly into the HANA Cloud as part of the mission. But as I said, you can extend it, right? So if you have all these text files or any kind of unstructured data format sitting into your data lake or file server, you could also use the Python scripts to have the data ingested into the HANA Cloud. And we used JSON specifically because if you have customers who are working on SaaS solutions, and if that's the case, then you could ingest the data as such, because the extracted API response would be in the form of JSON, and you do not have to manipulate and ingest into HANA Cloud because it's a multi-model platform. So that is step one. So once you have the text into HANA Cloud, the second step being that converting the text into the vectors that you need. So for that, we need to access the large language models. It is provided either by the Generative AI Hub, or you could also use Azure. We just use two different flavors with SAP and open source. And there are different large language models available today. You might have seen in the announcements for Sapphire, we have the partnership with AWS or GCP, and listed a lot of different providers. So specifically for embedding, we used Azure model. As I said, we explained about the embedding concept. So all your text that has to be converted to vector, you can access the large language model from Generative AI Hub, convert it to vector, and ingest it back to HANA. For this, we have given different Python scripts and different scenarios. In order to execute this as a whole, we use the LangChain plugin, which SAP has provided as part of the LangChain framework. And it's easier to use that. You just need to point which is the table, what is the embedding to use, and the framework takes care of doing all this ingestion process. And the second part being prompting and validating the test data. So for this, what we are given is we are given Python scripts as well as the CAP application. So you can prompt using the Python script, asking some question, and basically your question gets converted to a vector by accessing the large language model. And the user prompt, which is converted as a vector, goes and queries against the HANA Cloud, where all the vectors that has been ingested from the text is stored here, and takes all the closest vector information and corresponding text. And before presenting it to the user, since Generative AI Hub has a lot of different large language models, we thought of using Falcon, part of Hugging Face, to identify the sentiment of the text and then present it to the user. So basically, when the user queries about, like, show me all the feedback what I got this week, for this specific week, it will get all the closest text files by comparing the vectors. And for all the text files, it runs the text and understands whether it's a positive feedback or negative feedback, and it presents to the user. So this is the use case for the whole discovery mission. Okay, let me jump directly into the mission. Cicely has already shared the link for the mission. So specifically, if you go into the project board, the concepts, whatever about the HANA Cloud multi-model features and what is vector engine, the Gen AI Hub, what the provider is, and some of the concepts what we explained, you'll find it in the discovery phase. And in the preparation, the mission architecture overview is nothing but the slides what I showed you. That is what being mentioned, like what is the approach for the architecture. And specifically for the implementation, we have given these different scenarios. Maybe the first 6 scenarios corresponds to Python scripts, and the last scenario corresponds to a CAP application, with Anjana would be explaining it later. And for this 6 scenarios, we have a combination of using either our Generative AI Hub and HANA Cloud, or if you want to access the large language models from Azure OpenAI and HANA Cloud. So just to give like how it works with both to show you the difference. So this is what we have covered in the implementation. And the main important point is the setup phase, where you have to set up your AI core if you're using the Generative AI Hub. So a quick intro into it. So assuming that you have a sub account, we would expect you to have the entitlements for AI core and AI Launchpad. And with the AI Launchpad, you won't get access to all the large language models using the free tier. So you need to have a specific subscription, CPA or pay as you go, and then you will have access to the foundation models. So basically, you have to configure all these foundation models. So I'm going in on a high level, but don't worry, all the steps have been explained it as part of the discovery mission itself. So if you see here, you can select the foundation models, what you wanted to deploy. So first you have to configure the foundation models. And if you see there, you see all the providers, what is available. Specifically, we have been using the Azure OpenAI for the embedding and the open source for the Hugging Face models for using Falcon. So once you have all the configurations of different models on our Launchpad, you deploy the necessary models, because this deployment ID is needed for using it in the CAP application. For the Python, it's a different configuration that's needed. The configuration, what is needed is in your sub account, you would have your AI core. So for the AI core, you have to download the keys that's needed. So this is the key which is important. Maybe if you download it, I'll show you in the next steps on how you use it for executing in the Python scripts. So this is all related to the setup for the AI core, and specifically for the Azure part, if you wanted to use it. So that's also is possible. So with respect to Azure, like you have to create a request to get access to the OpenAI. And for that, I've added in the step, like in setting up Azure OpenAI, if you see the request access, basically you would go and access and provide your subscription information, and then you will get access to the large language models. So most importantly, when you create OpenAI keys, OpenAI provider, you will be getting access to the keys and the endpoint. This is necessary both for using for the Python scripts as well as for the CAP application. And you will also do the deployment similar to how we do the deployments in the Azure OpenAI. So in case of Azure, if you are using the embedding models, then you will be calling the deployment name. And if you're using the chat completion or any of the for the sentiment, any of those things, you'll be using the deployment made to call. And you'll also provide the combination of the key and then endpoint to access the large language model if you're using Azure. So these are the things what we covered as part of the setup phase. Yeah. And for the OpenAI, you just need to have a subscription, and directly you can use, there's only one key and you could be able to use it directly. And we have added as an optional step. The most important part of the mission is accessing the data. So as I mentioned before, you would be able to connect to your data lake and ingest the data too. But as part of the mission, we have provided you 2 schemas. If you're using the CPA subscription, then you would be able to import the schema what we gave. There is a combination of JSON documents available. Also, the table is available. But if you're using a free tier HANA Cloud, you will not have the document store enabled. So we have given you a separate schema which just has the relational table. So if you have HANA Cloud with CPA subscription, one of the important points to notice, you have to enable the document store if you wanted to use the JSON documents as part of this whole process. When I talk about the JSON documents, let me quickly show you what I'm talking about. This is my HANA Cloud Database Explorer. And if I try to import the catalog objects, this is the schema that we provided as part of the mission. And if you see here, it shows you the JSON document as well as the relational table. And when you click import, it gets imported into your schema. It creates a schema called vector_demo. And specifically to show you what we are talking about, let me go here. This is the schema what we used. And if you see here, we have this JSON documents. So this you can assume that if you're working with the SaaS solutions, it's more possible that I could ingest the JSON documents directly into HANA Cloud. And you could use our Python libraries, HANA_ML, and you have specifically a method to ingest that JSON document as such. So if you see here, you would be able to view the JSON data here, and it shows in the form of similar to how you extract from a SaaS solution. But as part of this whole scripts, I've been using text and also using the file name, because when a prompt from the business user comes from the front end, we wanted to show the closest text, and also we wanted to show the source file from where it's coming from. So we are just focusing on the file name and the text that's being used. So that's the purpose of using this. So if you see here, the file name and the text, I'm directly pinging the JSON document, and it shows me the file name and the corresponding text. So this is what we are saying, that you don't have to manipulate the data and store it as relational. You can just ingest it as a JSON document into HANA. So this part we have covered here as part of the data that is needed for the mission. So hopefully you'll be able to set up either Azure OpenAI or the GenAI Hub, and most importantly, the data that is needed. And the second thing is the code repository. Again, we have split it for Python separately for using the GenAI Hub, as well as the Python scripts that's needed for the Azure OpenAI. Let me execute one each of the scenarios to show you what it is. And when you log into the Python scripts, you do have access to the Git repository. And this would be the Git repository where you have the different scenarios. If you remember, I was talking to you about 6 different Python scenarios. Maybe one of the example being that use the standard LangChain plugin provided by SAP and use our Generative AI Hub. And how do you read the data and ingest as embeddings into the HANA Cloud? Yeah, so all the corresponding scenarios are provided here, and it's also well documented. And I'm just going to show you directly from my Visual Studio. So this is the scenario 2. And we have added enough steps and enough documentation within the code to understand how the sequence is. Now, before you execute the code, if you remember, we downloaded the JSON keys for the AA code from here. So if you're using Generative AI Hub, then more importantly, some of the libraries that you need to install to start with this Generative AI Hub SDK. Once, if you have installed this, then you'll get access to this AA core configure. So this would ask you, like, give me the authorization URL, client ID, client secret, and all this information. And that information, you can get it from this key, and you can provide it here. So this is how your access to large language models from our GenAI Hub Foundation, you would be able to access it via the Python script using the SDK libraries. Yeah. And if you wanted to directly use it in Colab or execute from the session, that's also is possible. And we have provided the scenarios as part of the mission itself. Like if you go in, we would have given the steps for different scenarios. For example, if you go here, how do you install on the Colab, and how do you set up the key, what is needed, that's also provided as part of this. Let me explain one scenario on how this works end to end. So this is the scenario 2, where we are going to access the data from HANA Cloud, where we ingested it as a document, read it, and use our LangChain framework and move the data and convert it into vectors. So I'm initiating the class for OpenAI embeddings. The reason being that I have had the deployment for Azure OpenAI embedding. And for the LangChain, it is a community where they provide access to frameworks for different vector stores. And HANA Cloud is one of the vector stores. So that's why we use the HANA vector. And importantly, we provide all the necessary credentials connecting to HANA Cloud, what would be the schema where you want to ingest, and what would be the target table, where you wanted to ingest to. So let me just give it as June_reviews. This would be the target table where I would ingest the data by reading the actual data from the text. And here you will see the vector information store. So basically giving the HANA credentials and establishing the connection to HANA. And all this I'm having it in the environment file, just why you see it as a variable here. And once you establish the connection, I'm specifically saying that since I use the AI Core Configure, I'm saying that I wanted to access only the embedding model, which coming from the Generative AI Hub. And because of the OpenAI embeddings, and that is because that is the method which we initiated from our Gen AI Hub. And the next step being, we have to read the data, the source file, where all the documents are. So if you remember, I'm just trying to execute it from the HANA Cloud. Let me go here. And if you see in the Database Explorer, I already have it. So if you execute this, basically it's reading from the existing schema. It's reading all these 100 files and corresponding text. So that's all it's doing. And once it reads the text file, so this is the most important part, where we say that, hey, what is the HANA Cloud connection I need to use? What is the embedding model I need to use? What is the target table name? And which is the text I need to embed? What should be the target column where it has to be used? And what is the source file that needs to be used? So this will be the actual content. Either you validate from the Python or from the CAP application when you try to, So this is the information, and once you provide this, then it creates the table successfully in the HANA Cloud. Just to validate it, let me try to run this specific scenario. And we have added the table name as, if you remember, we have added the table name as garage June_reviews. So let me save this and execute this again. So it's going to go through a sequence and establishing the connection to HANA, trying to understand what's the default schema, and then changing the default schema to the current schema name, what I wanted to have it as. Okay, let me close this and try to open this again. In case if it doesn't work, I'll show you directly in the system from the tables point of view what we created in the demo today. I'll just use this as a backend at this point, but let it generate. So it's creating it, it's trying to understand the user. But if you see here, this is the text, what it generates, and what is the corresponding file name, and what will be the vector that is generated as part of this whole process. So that is what this, okay, it's created the garage June_reviews. If you go back and I search for that, yeah, so this is the table which is available. And there's one thing I'll do if you want to see the whole vector. So if you see here, this is the text which we ingested from the external file, and this is the name of the source file, and this is the corresponding vector that's been ingested. So this is the framework which helps us to do it end-to-end. And this we are completely using the Generative AI Hub. But if you wanted to use the Azure OpenAI, the flow is exactly the same. But the only difference is we will be using the Azure OpenAI embeddings instead of our Generative AI Hub class. And most importantly is to instantiate the model. We will use the Azure OpenAI embeddings. And this is the model and the endpoint we use and the key. And where do you get this from? And this is from the Azure. So I have the key, I have the endpoint, and for the deployment, I use T for SAP, which is coming from embedding model. And that is the model which I use it. So this is the only difference. Yeah, so this is more about, I'm extremely sorry, give a minute. Sorry, what? So this is how you do it. And one of the final script which I wanted to show you is the validation of the query itself. So if you see the architecture, what we shared, one of the thing is the user prompts from the front end, and the prompt is converted to a vector connecting to the large language model. And the vector information is queried against the HANA cloud. And then finally, we are sending it back to the user with the sentiment. So we are using different large language models here. That scenario we have covered in scenario 5 and 6. In scenario 5, we are using the GenAI Hub. And in scenario 6, we have used the Azure OpenAI. So basically, as I said, we could also use SQL to query all the different kinds of metrics for the vector. So for example, see that from the cap, if you're trying to call the prompt. In this case, I've just used what is the reviews about tacos. Even though we use it for the medical industry, the test data what we gave is more about some customer reviews about different restaurants. So this is the user prompt. So we convert this user prompt into a vector using the embedding model T for SAP from Azure. And once I have it as vector, then I run the select statement on HANA Cloud, trying to understand what is the closest vector for this reviews that I get from the HANA Cloud that's been ingested. And I would be getting the file name, text, and the scoring. And that is step 1, using the large language model for embedding. And step 2 being, once I have this text, I want to understand the sentiment for the text. So for this, I'm saying that provide the sentiment for every closest text that we got. And for that, I'm using A for SAP, which is nothing but one of the model for DaVinci, which I used to understand the sentiment. So basically, similarly, you would be able to use it from the generative AI hub too. And if I execute it directly from here, so in this case, what happens is like it will again establish the connection to Azure at this point and get access to 2 different large language models. And finally, for this particular reviews, it says that if you see the response here, it says that these are the 10 different closest text files that we got related to the tacos, which is good, which all talks about different food. And this is the closest scoring we got. And since we asked for the sentiment for each and every text, so for this, it gives you the different sentiments. So it also identifies for the business to understand which are the content to look first and not, and also if you have multiple large language models, you can get the response of one large language model and you could use it for the second. And if you're using a LangChain framework, you can think about using chains and then using it for your applications. So all this, what I showed you, is also available as part of your missions, and all the Python scripts for the code repository, and how do you validate using GenAI Hub. And similarly, how do you use for the Azure OpenAI, and how do you validate using the Azure OpenAI embeddings too. So these are the scenarios for the Python. And for the RAG, I hand it over to Angela. Over to you, Angela.
Yeah, thank you, Vivek. Let me share my screen. So, like Vivek mentioned, so the next part of the demo, we would be looking at how we have created a RAG application, using CAP. So this is, development, that is SAP using, developing the RAG application using SAP Cloud Application Programming Model. And what we will be talking here or looking at here is more how, the CAP application in itself, it interacts with the LLM models, which we have configured in the Generative AI Hub, and also how it queries the underlying vector database tables and, gives the responses which are similar to the user prompt which we have entered. So we have created a similarity search application, something similar to what we saw right now when Vivek showed the Python scripts. So what it does is based on the end user prompt, it gives you the similar responses based on the similarity scoring. So the example which we have taken here is, a simple example where, the customer or the end user asks for a review about a restaurant, and it, generates a response which are, similar or closer to the prompt which the end user has entered. So before I go into the mission itself, I just want to quickly show you the application, and then we see how this was implemented. So this is, like I said, we have created a very basic HTML5 application, which, with the input area, which just takes the user prompt. And click on submit, it basically gives you the response. So the response is, again, very similar to what we saw, where we have the file name, which is the source in itself from where the response is coming, the text, which is the response, and then the scoring, which is the similarity scoring, which tells you how similar your response is to the user prompt which you have entered. And in addition, we are also doing sentiment analysis on the response to know, what is the emotion or the positive or the negative feedback behind the response as such. So here, like I said, so here this is again based on the vector embeddings, or the vector database table which you have created, which we have created in the previous demos. And the end user prompt is basically converted into a text embedding, and then there is a similarity scoring which is performed. Basically, it compares the text embeddings which you have in your vector database tables, and then generates the response. So now, so this is the application in itself. So moving on, to the mission. So if I go to the mission, the first step is, how to set up the CAP project, right? So before we set up the CAP project, there are certain prerequisites which is needed from a subscription or from an entitlement perspective. So if I go to the BTP cockpit, obviously we need the HANA Cloud subscription. So looking in. Yeah, so we need the SAP HANA Cloud subscription to, for the CAP application to deploy its database artifacts. We would need if you are using SAP Generative AI Hub, then the AI Launchpad subscription, as well as the Business Application Studio for developing your CAP application itself. And in addition to that, we also need certain entitlements, other entitlements as well, which we need to set up. So basically, we need to have the destination services, because so for the CAP to interact with the LLM models, it uses the destination services which are available in BTP cockpit. So it needs the entitlement has to be maintained for the destination services. Similarly, we also need entitlements for let me come here for the HTML5 repository, because we also have HTML5. This is a HTML5 application. And if we need to host it in the server in the Cloud Foundry, then we also need the HTML5 apps repo entitlement, as well as we also need the XSUA if you're enabling authentication or authorization for your application. So these are some of the entitlements and subscriptions which is needed as a prerequisite. So let me then move on to the cards. So initially, so the first step is, basically you need to clone your CAP application. So we have given the source code as part of this GitHub project. So, for the sake of time, we have already cloned this. So initially, before you start with the BAS, so you need to create a dev space in your Business Application Studio. So you need to create a dev space. You can use your existing dev space as long as it is a full stack cloud application. So here you can see I have multiple dev spaces, but for the application to run, it should be a full stack cloud application. So once you have created the dev space, you need to clone your Git repository. So you can use Git clone, where you pass the repository URL, which I have shared and which is there in the mission. And this basically clones your CAP project into your Business Application Studio. So once you have cloned the project, there are different modules which are involved. So we have the app module, which basically has your web application, the basic HTML5 application which we have created. It also has the router, which is basically your app router module, which acts like a gateway when you send requests from the browser, to either route it to the HTML5 apps or to route it to the services and so on. And we also have the HTML5 deployer, which is, for deploying the HTML apps into Cloud Foundry. And if I look at the project, or which is basically the web app, this follows a view controller model, which is, where we have the view file, which has the basic HTML5 controls defined, where we have the text area, where we have the button, basically the submit button, and then we also have the output. And similarly, we have the controller file, which is corresponding to that view, where we have defined one function that is called as on submit. So this on submit, on click on the submit button, the on submit function gets called, and this internally calls the connect to Gen AI service, which is a function which we have defined in the service layer in the CAP application. So, and here we are passing the prompt, which is passed in the input area by the end user. So coming to the service layer, so now we have called the connect to Gen AI service. So we go to the service layer. So in the service, so your SRE module is basically your service layer, which is implemented using Node.js. And in the service layer, we have the service.cds file where we have defined the OData service in itself. And we are exposing the entity, which is the reviews target entity, which is a table which we just saw, which was created as part for the demo. And we also have other actions like connect to Gen AI and connect to OpenAI, where we have the logic basically for the interactions with the LLM models, as well as how to query the underlying vector database tables. Here we also have the cat service. The service.js file is basically your custom handler, where we define what is the logic inside each of these actions. So if you go to the AI code.js, which is kind of like a utility file, you see there are two functions defined here, which is one is connect to generative AI, which is basically used if you're using SAP Generative AI Hub. And we also have one more function, which is the connect to OpenAI, that is used if you're using the Azure OpenAI LLM models. So we will be looking at this particular model, which is this particular function, which is the connect to Gen AI. So here, like I said initially, so we need to, when CAP application needs to interact with the LLM models, we need to use destination service instances, which is available in BTP. So that is not specific to LLM as such, but if in CAP application, if you're using any kind of REST services, then we need to access those REST services using the destination services. So we have defined two destination services here. One is the AI Code Destination Hub, and then we have the Open AI Code Destination. So here, first, what we do is we also need to define basically what is the embedding deployment ID and the sentiment deployment ID. So this is basically what Vivek was showing earlier in the AI Launchpad, where we have the embedding deployment ID associated to the embedding model, and the sentiment deployment ID associated to the Falcon model, which we are using. So here we have maintained those values. And what we do is this value and these values are basically the user input is passed to the embeddings API, which gives you the text embedding associated to it. So in this particular code, as you can see here, we're calling the REST API, which is exposed by the AI core service instance. We call the embeddings API, and we pass the data, which is the input, user input, which is provided. And this gives us the text embedding associated to it. Once we have the text embedding, what happens is we need to query basically your vector table based on this text embedding to get the top 10 responses, which are similar to your the user prompt. So here we have a select query on that particular reviews underscore target table, where we get the top 10 responses. We get the file name, which is basically the source, the response in itself. And we also get the similarity scoring, what we saw in our application, in our UI5 application, where we do the cosine similarity function, which gives us the similarity scoring. And based on the scoring, we read from this reviews target table. Based on the scoring, we get the top 10 responses. So here we are querying the vector table based on the embedding we received, and basically this result has the top 10 responses similar based on the similarity scoring. Now, once we have the responses, we again have an additional logic to identify the sentiment behind each of these responses. So we again use the destination service instance. So we loop through these responses which we have received. We have a prompt, something like provide sentiment in exactly one word for the response. And again, this is called using the destination service instance, where we call a different API this time, the completions API, and the deployment, the model also is different. Here we call the Falcon model to get the sentiment behind each of them. And once we have the sentiment, then this is, finally being pushed back or sent back to the end user in the Fiori, in the UI5 application. So this is, the service layer. And if I quickly show the DB module. So we said that initially in the initial slides, we also talked about how CAP supports vector data type. So here, as you can see, we have exposed the reviews underscore target table as a CDS entity. Since this is an existing entity, we have added the cds.persistence.exists annotation. And here we have the file name and the text. And for vector, we have defined the data type as cds.vector, which is the data types, the CAP data type for vector columns. And recently we also have, they have also supports, you can also define length for this data type, where you can specify the limit for the dimensions as well. So here, basically you are exposing your table as a CDS entity, and basically the select what you saw in your AI code.js is on this reviews underscore target CDS entity. So so this is, the basic flow, the different modules which are involved, in the RAG application which we have. So let me quickly go back to the cards. So here we have we clone the GitHub repo. We saw the different modules. The next step is, we need to create a destination service instance. So like I said, we need destination service instances to call the REST APIs from LLM. So we need this step basically to test it from a local perspective. That is, if you're testing locally, then you need to create a destination service instance. So you say create service destination light, and it says it's already existing in my particular space. Once we have the destination service instance created, we also need to create a UPS vector, or basically a user provided service. So this acts more like a, this is like the reviews underscore target is created in a different table, which is a schema, which is in vector underscore demo, or it's created in a different HDI container. And the CAP in itself has its own HDI container. So for cross-container access, we are saying that, okay, we need to create a user-provided service saying, and this user, particularly this user, should have a select with grant on vector underscore demo. And if you look at the files, there is also we also create an HDB grants file where we say that, okay, this particular user, or basically the object, let me show you. The object owner and the application user of this application, has privileges to select on this particular schema. So this is more, with respect to cross-container access in itself. So once you have defined the service instance and the UPS vector, the next step is, basically you need to create your destinations, right? So we talked about using destination instances, but where do we define that, right? So we need to basically define your destinations in the BTP cockpit. So if you go to a BTP cockpit, there is this destinations which is available. And here you need to create destinations for each of the scenarios. So for example, if you're using generative AI hub, so this is the destination which we have created. And for Azure OpenAI, we have used another destination. And if you look at the configurations, what we have done here, I'll just quickly switch to the PowerPoint. So what we have here is we have, the destination name, which is exactly the same name what we have in the code. We also have the URL maintained. So this URL is basically coming from the service key, which Vivek showed, which Vivek downloaded for his Python scripts. So this is coming from the same AI core service instance URL, and this is what is being used here as well. And this needs OAuth client credentials. So basically your AI core service instance would also have the client ID and the client secret associated to it. And similarly, the token service URL. So just to show you that, so this is the default AI core, which was there, which Vivek just showed in the system. And if you open the view credentials, it would look something like this, where you have the AI_API URL, which is the URL, which is basically your REST API URL to use the LLM models in the generative AI hub. And then we also have the client ID and the client secret. So going back, so once we have defined that, the destinations are defined, we also need to change the deployment ID and the sentiment deployment ID based on, the way you have configured your AI Launchpad. So we already saw the deployment ID and the sentiment deployment ID from the AI Core Launchpad, and that is what we have also maintained in our application as well. So if you see here in our AI Core, we have maintained the embeddings, which is the same embedding model which we have used for ingestion, as well as, this is the Falcon model, which gives the sentiment associated to it. So, so now we have set up the code, we have set up the prerequisites, and we have created the service instance. So the next step is, how you can run the service. So we also have one more card for Azure OpenAI. So this is very similar to what we saw. So when you go through the mission, you can also take a look into it. And the next step is basically how you can run this locally if you want to test your application. So basically, you need to bind your existing, database to an HDI container. So let me quickly go through it. Yeah. So here, if you open SAP, when you come to your Business Application Studio, you have your SAP HANA projects. And here you would see there are different options. You see all your database artifacts in here. So initially you need to, bind it to an HDI container. So here, currently I've already bound it. So if you have not bound it here, you will have an option called as bind. And once you bind it, this is bound to a HDI service instance. And you should also bind your cross-container service to the UPS-vector. So this is basically for the cross-container access as well. So once you bind these two, you need to basically, deploy. You need to also run a CDS build. So what does a CDS build do is it basically builds your underlying, your CDS entities and creates corresponding views for it. So we do a CDS build. It generates the HANA views for the CDS entities and for the CDS services. And once we do that, we need to perform a deploy in our local container. So you do, deploy, and this should ideally get deployed to the service instance which we just created. And once we do that, we also need to bind. Basically, we need to bind our. Sorry, come here. Yeah. We also need to bind the service instances so that to our CAP application, so that we can run it locally. So the command is something like this, where we say CDS bind this particular. So we say CDS bind LLM cap HDI3 to shared dev key. Similarly, we also need to do this for the destinations as well, so that we have the environment variables defined with this LLM cap HDI3 as well as the destination. And once we do this, we also need to do an npm install so that all the required packages are downloaded when we are running this in a hybrid mode. So after that, if you do a CDS watch profile, if you run the command CDS watch profile hybrid, then it automatically runs the. Yeah. So here, you would see that this automatically opens the web application, and you can, you see the similar UI as to what we saw earlier. Considering the time, I'll just quickly move on to the next card. You can also, deploy this application. So basically, you can deploy it like how you deploy any CAP application, where you build your MTAR, MTA, and then when you build your MTA, you get your MTAR file. Sorry, yeah, so you do build MTA, and basically the build MTA will build your application, and then this would deploy your MTAR. So you have something called MTA archives where you can deploy it into your Cloud Foundry. And once you deploy it, you would see something like this where you have, where you have these three applications, where one for DB, one for service, and one for CAP. And if you open the URL, associated to CAP, you would again see the web application. So this is the way you can, implement or basically create the basic CAP application for RAC. Yeah, that's it from my side. Vivek, over to you.
Thank you, Anjana. And I think I just have one final slide to show. And let me know when you see it, because this is more about the benchmarking. We didn't include in the mission, but I thought this would be good to know for you, because we started testing this with different large language models, right? So whatever the mission has, it is more about test data. But really, if you have some volumes of documents and you have to embed and do it, there are a few things which come into it, right? I mean, like most importantly, on what kind of compute you're executing. And if you're using large language models, there is this concept of tokens per minute and requests per minute. I also see the question in the chat, like one of the experts were asking about, like if I have larger text, right? So in one of the scenarios, for scenario one in the Python script, we'd have used something called a tick token. Tick token meaning that before you send a request to a large language model, it will identify the token length of the text. So the token length of this text should not be greater than the token length which a large language model could process. For example, if you're using Azure embedding, it could be 2048 or it could be 4000, depending upon from where you are accessing the Azure OpenAI embedding model. But if your text is greater than the token what it could handle, then it means you have to split the text and send it. So, and also at some point in time, you could parallelize the whole embedding process, meaning that you could use PySpark and you could trigger it and all those things. But again, for example, if I was using the APIs from Azure OpenAI directly, running for a batch of 20,000 text files, which did not exceed the length of what the embedding token from Azure would go, it took around 70 minutes. It was more like a kind of a sequential way of doing it, And when I used the LangChain plugin, and when we tried it, it drastically reduced it because it knows how to parallelize this and then how to execute it end to end. This is more about the embedding part. And more towards the end, if you want to reduce the whole embedding, then even, for example, if you're using Azure, one of the things what you will hit is something called quota. If I wanted to show you directly here, so if you see the large language models, whatever we have used, so there comes this concept of quota. So if you send more than certain requests per minute, if you see here for the embedding, we always hit the usage because it's 100% we are using when we are testing it. So when you have to increase, then you have to request the Azure to increase, or when you're using GenAI Hub, you should reach out to SAP where they will increase the quota. And then you would be able to do it a lot of requests in parallel. But at the same point in time, we would highly suggest you to also have two different embedding models in two different regions and try to run it in batches. It might further reduce the time of embedding part, But a lot of these things, once you try to productionalize it and then start using it, you will look into this, what kind of compute you use, whether should I do it in batches, if I use Spark, or I have to do it, or if I'm using Azure OpenAI, then I have to personally go and have them increase the quota. But if I'm using GenAI Hub, you can have it done to provision the throughput via SAP, which would be much easier. So all these different kinds of metrics you would have to consider when you do it like a production-like scenario. And the template what we gave in the mission helps you to understand the basics. And once you start the mission, if you have more questions about how do you productionalize it and use it, we are more than happy to help you out through the chat interface in the mission. With that, that ends our session on what we wanted to show and demo it, and hopefully you find it useful. And over to you, Cicely.
Yes, thank you, Vivek. Thank you, Anjana. I've seen a lot of activity going on in the chat, so thank you to Vivek and Unadi for answering the questions so far. Unfortunately, we have reached the hour, but I appreciate everybody so much for joining us today. A big thank you to Anjana, Unadi, and Vivek for presenting and for giving us this nice information, and also for providing the helpful Discovery Center mission. As Vivek mentioned, there is also an option to contact the experts within the Discovery Center mission. So if you do have any further questions or want to ask anything, I saw some of the questions were very specific and some were more general, but you can always reach them there as well. And yeah, with that, like I said, the recording will be made available on YouTube. I will post that link one more time. And thank you guys so much. And I hope to see you in our next garage session in July. Thank you so much. Have a great day.
Thank you all.
Thank you. Bye.